Hi, so I'm going to teach you in this tutorial how to add vectors that are at right angles to each other using geometry and trigonometry. So we got to learn your SOHCAHTOA, or remind you of your SOHCAHTOA. I'm also going to teach you how to do the reverse of adding two vectors. In other words, well, let me show you. So you don't have to write anything down here. I'm just going to show you, we learned previously that if I have two or more vectors, let's say A and B, and they are connected, let's say like this, I want to draw a result, the vector sum of them. So I could make a parallelogram, in this case a rectangle, and that's going to be R. So now we're going to learn that if this is, let's say 6 or 8, and this is 6, we're going to learn how to figure out that this is 10. Okay, it's not difficult. The more difficult part is then we're going to have to learn how to calculate that angle using trigonometry. So SOHCAHTOA is something you want to recall from earlier days in math. Sine equals opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. I'm not going to teach you that. You should know that. So it's just an issue of you reminding yourself how to do that when we do these problems. You can do it. You just got to be willing to put a little work into it. So we're going to build this lesson around a problem, and then I'll do some other examples. Okay. So let's say I have a plane moving due north at a certain speed, and then a wind blows it east at another speed. So what is the magnitude? In other words, what's the sum of those two numbers in the direction of the plane's speed? So the plane just flies north. It should go north, but if it's being blown east, then it's going to move north and east at the same time, and we're going to add those two speeds. So if I haven't already taught you this, and I will do it eventually, there's another one way we can do it is graphically. We could use a protractor and a ruler and draw things to scale. But here we don't have to do that. We're going to just use the idea of proportions and triangles matches what's going on with our actual velocities. So I've got 4 steps. So first we're going to draw a sketch. This is so important. Of the velocity vectors, so we can line them up so we can draw the correct resultant and before we determine the magnitude and direction of that. And it does not need to be to scale. So I've got this big space off to the left here. So I want a northward vector and an eastward vector. Don't do what I'm going to do now. But one way you could do it, don't draw this, is I could draw a northward vector representing the 250 or 200, and I could draw an eastward vector. Whoops. That would be west. Let me try to do a better job. So I got to anticipate where things are going to go. So I could draw a north and I could draw an east. That's fine, but that just makes our life a little bit more difficult. Okay? A smarter way, so what I've done is I've drawn them tail to tail. So our resultant is going to be somewhere in that general direction. That's the direction the plane is actually going to go, north and east. A simpler way of doing it, and one I highly recommend, is draw them tip to tail. So if I draw my first vector as my north vector, so I'm just going to draw, and I'm going to label this to 200. Then if I want to put the eastward vector, put it at the end of the north vector, and something like that. Okay, so what I want you to recognize here, then we can immediately sketch our resultant. Our resultant looks like that. That's R. So we want to find that value, and I want to find what value this is pointing. And if I look at my right triangle, I see this is the angle that can help me find the pointing. Okay? The other option is, if I draw a dashed line, is find that angle. But since we have our vector triangle, and we always want to measure angle at the end of the, or at the base of the vector in question, okay, this being the base, the tail part of it, that's what we do. So now it's just an issue of trigonometry. Okay, so we've drawn the resultant and I've drawn the angle. Draw the resultant and angle. It's really important you do that so that the trig makes sense later on. So notice that we have a right angle here, or a right triangle there. So if this side is 200 and this side is 50, this resultant is essentially the hypotenuse of that right triangle. So I can use Pythagorean Theorem. So I can say my vector A squared, so I'm going to find R here, 200 squared plus 50 squared equals my resultant squared. So my resultant, the sum of 250 is going to be the square root of this whole thing. So get out your calculator and punch this out. So press pause to do this. So under the radical sign, we should have 42,500. Therefore, R equals the square root of that, roughly, I'm just going to round, 206 kilometers per hour. So let's make sure we understand what that 206 is telling us. It is the vector sum of 200 plus 50 when they're at right angles to each other. If I had 250 like this, then they'd add up to 250. But the wind is not blowing in our direction, it's blowing across us. So the plane is going to move at that speed. That's the sum of those two. Now, if you're a pilot, it's important to know how fast you're going, but it's also just as important to know what direction I'm going so I can make sure I get to my destination. So we want to find this angle theta. Well, we got a right triangle, and we know this side and this side given. We do know r now, but since we rounded it, we're going to ignore that we know it. So what I want you to recognize is that we can find this angle by using a trig function. Again, that's SOHCAHTOA. Since we know the opposite side, that's O, and that's the adjacent side, we can use the tangent function, right? We can use a TOA, which says tan equals opposite over adjacent. So what I'm going to do is to find that angle theta, I'm going to say the tangent of that angle theta equals opposite 50 divided by 200. Now on your calculator, you got to make sure you're in degree mode. You might be in radian mode from math class. So change the degree mode right now because I want you to work this out because a lot of students aren't quite sure what buttons to press on their calculator. So first of all, take 50 divided by 200. That's 0.25. Now that's not an angle. The tangent of the angle is 0.25. So to find the angle, you take the inverse tangent. So tan negative 1 of 0.25. So on your calculator, that would be second tan 0.25. And if you do that, you get 87 degrees, or 87.7 degrees. So this angle is 87.7 degrees. That's awesome. We got to add one more thing to it. We got to reference that to north, south, east, or west. And this is building on the lesson from the previous lesson. So if this is north, whoops, this is east. Let's look at this angle. So we want to reference that angle to one of those directions. Well, in our triangle, this is not an angle, or this is not a direction, but this is, right? There's my north. So we're moving this way relative to north. Which way is what I moved there? That's east. So that's 87.7 degrees east of north. Okay, so look at that carefully. Make sure you know how to get the 87.7 degrees from your calculator. So that's basically it on how to add vectors. So I'm going to give you below another example, a little bit more difficult, but it's the same idea. In this case, we're going to have 3 vectors. So in this situation, we have something walking 4 city blocks west, then south, another 5 city blocks, and then west again for 8 city blocks. So there's 3 stages to this, and we want to find what's the displacement of the rhino here. So first thing we're going to do is we're going to sketch those vectors so we're going to try to make a right triangle of this whole thing, even though it's not going to look like it initially. So I'm going to start here. I'm going to start over here because west is left. So I'm going to go west, and I'm going to call that 4. Then we turn south. South, so I'm going to keep going from the end of that, and we went 5. And then we went west again, 8. So then we're going to go over here, 8. And again, I don't have to draw these to scale, but I want to get an idea of what it looks like. So the resultant of this is the vector sum of those 3. So I go at the beginning of the first, and I go to the end of the last, and I draw a line. That's my resultant R. I need to find that value. And I'm trying to teach you how to do that using a right triangle. So here's what I want you to recognize. My right triangle that encompasses that R, I want to make a right triangle, so that's my hypotenuse, is this right triangle right there. So I just need to find the base of the 2 bases of these. Well, this is going to be 5 because that's 5, and the long base is going to be 8 plus 4. That's 12. Okay, now that I have that, then it's pretty easy to use Pythagorean Theorem. So I would say R squared equals 12 squared plus 5 squared. Therefore, R equals the square root of 169, and that's equal to 13. Okay, so R is 13. That's the easy part. We're 13 blocks away from where we started. Now we have to find the angle. So the angle is within my triangle, and it's from the base, or like the beginning of my resultant vector. So here is the beginning of the resultant vector. So this is the angle I want to find. So I got a reference. So I want to set up my trig. So I want to say the tangent of that angle equals opposite. So my opposite is opposite this angle is right here, is 12, and then divided by 5. So my angle, theta, is going to be the inverse tan. What's 12 divided by 5? Well, that's 2.4. So on my calculator, I type inverse tan of 2.4. And that gives me about theta of 67.3 degrees. And then I have to reference that to north, south, east, or west. So here's my angle here. This line is south. So I'm going over to the left of south. Left of south is west of south. Since all our motion was south and west, we expect that to be one or the other. Now, let's go to the reverse of this. Okay, so the next thing we're going to learn is how to take a vector and break it into components. And this is super important for what we're going to be doing next in projectile motion. Okay, so what I mean by breaking in components is if I have a vector that's pointing that way, we can say that's pointing right and up. So I want to be able to split that into a rightward vector and an upward vector such that I make a right triangle. So if this is R, then this would be Rx in the horizontal position. This would be Ry in the vertical position. So it's really just a reverse of taking two right angle vectors and making a hypotenuse. We're taking a hypotenuse and making two bases to make a right triangle. Okay? So let's say, again, I'm going to build how we do this around an example. So let's say Jack Sparrow hides a chest of gold, whatever, and it's 200 meters from a rock on the beach. So let's say here's some rock. And it's 200 meters, but 200 meters could be anywhere from that rock. So we're going to use specific directions. So he's going to go 37 degrees south of west of the rock. So that's where the treasure is. So let's see, south is this way, west is that way. We want to go south of west. So west is here, we're going to go south of it, so our treasure is right there. So if he wants to get from here to here, and he wants to do it in two stages, he wants to go south then west, we want to basically find the results of that. So there is the direct route to his treasure. But what I'm saying is, okay, we want to go south, because maybe there's danger along that route, and then we want to turn west. So there's our vector. I'm going to call it R south and R west. I want to find the values of each of those. And this angle, hold on a second. All right, I've got that. I drew that wrong. So let me redraw it. So there's the 200 vector from where he's starting to the treasure. The angle is given south of west. So in order to match that, we want to go west first and then south. Okay, so this is our 37 degrees. Now I'm going to call this A, and let's just call this B. So I want to find out how big is A and B, knowing the hypotenuse and that angle. And that's really just SOHCAHTOA. So what I can see is, let's take A first. If this is adjacent, this is opposite, and this is hypotenuse, and I know hypotenuse and the angle, then I want you to recognize that to find the adjacent side, I'd use a cosine of the function. In other words, I'd say the cosine of 37 equals adjacent, right? That's what I'm looking for, divided by hypotenuse, which is 200. So in other words, the A is simply 200 times the cosine of 37. And then B is the opposite side, and that's the sine function. So I'd say sine of 37 equals B over 200. Therefore, B equals 200 sine 37. You can work out the numbers for that on your calculator, but it's really, really important that you understand how to get this. In your reference tables, you will see right below your kinematics equations, you will see something that says AX equals A cosine theta, and AY equals A sine theta. So the reference tables help you do the components. If you want an X component, almost always it's going to go by the cosine of the angle, and the Y component is going to go by the sine of the angle. All right, I'm going to stop here, and then I'm going to start another short video to show you, give you more practice with how to take vectors, break them up into components, and then find the values of the vertical and horizontal components. Really important practice to get that before we do any homework.